Hello students, today we are going to discuss equations of motions. Okay, in kinematics, these equations are very important. So based on these equations, so we have many problems. Okay, the equations of motions are the relations between the displacement, okay, and u. What is u here? Initial velocity. And v. What is v? V is the final velocity. And t. So t is the time of motion. And a. So what is a? Acceleration. So here a is a constant. So in these equations we take a is the constant. So whenever the acceleration of the object is constant, then the motion is said to be uniform acceleration motion. That's why these three equations are known as equations of uniform acceleration motion. So the equations of uniform acceleration motion. These equations gives the relation between u s displacement, u initial velocity, v final velocity of the object, t time of motion, and acceleration of an object which is in uniform acceleration motion. Okay, now we have three equations of motion. So the first one is v is equal to u plus at, and the second equation of motion is s is equal to ut plus of at square, ut plus of at square, and the third equation is v square minus u square is equal to 2as. So these are the three equations of motion. So v is equal to u plus at, s is equal to ut plus of at square, and v square minus u square is equal to 2as. Okay, now we derive these equations. Okay, first of all we derive first equation of motion, that is v is equal to u plus at. So already we know that what is acceleration. Acceleration is the change in velocity for unit time. So that is a is equal to v minus u, that is final velocity minus initial velocity by time taken. So from this, if we move t to LHS side, that is at is equal to v minus u, and from this equation we write v is equal to, if we take minus u to the LHS side, so that is u plus u. That's why v is equal to u plus at. So this is equation 1, first equation of motion, v is equal to u plus at. And now the second equation of motion. So what is second equation of motion? S is equal to ut plus of at square. So already we know that what is displacement. So displacement is the average velocity into time. So the displacement is given by average velocity into time. So what is average velocity? If an object have u and v velocity, initial velocity and final velocity, then the average velocity of object is u plus v by 2. So this is average velocity into time. So we know that from first equation of motion, v is equal to u plus at. So substitute in place of v, u plus at. So substitute, that's why the equation becomes u plus at by 2 into t. So now u plus u, 2u plus at by 2 into t. So multiply with t, we get 2ut by 2 plus a t square by 2. So and 2, here 2 gets cancelled, and the remaining term is ut plus of at square, that is s is equal to ut plus of at square. This is second equation of motion. Now third equation of motion. What is third equation of motion? V square minus u square is equal to 2as. So this equation derived from using of first and second equations. By using of these two equations, we derive the third equation of motion. So what is that? So from equation 1, v is equal to at. From this, what is time? So if we move u into LHS side, v minus u, and if we take a to the LHS side, that is by a, that is the time t is equal to v minus u by a. Okay, now from equation 2. What is equation 2? S is equal to ut plus of at square. So now substitute this t value in second equation. So substitute t value in above equation, that is second equation. So now we substitute the t value in equation 2. What we get? S is equal to u. In place of t, what we write? V minus u by a plus 1 by 2 a. In place of t square, what we write? V minus u by a square. Okay, now multiply with u. So u into v, uv, u into u. So minus u into minus u square by a plus 1 by 2 a. So here v minus u whole square. So we already know an algebraic equation, that is a minus b whole square is equal to a square plus b square minus 2ab. That's why here v minus u whole square. What we have? What we get? V square plus u square minus 2uv by a also in the within the bracket. That's why a square. So here a 1a cancel, and the remaining terms are uv minus u square by a here plus v square plus u square minus 2av by 2 into a 2a. So now we take LCM for the both terms, LCM for the two terms. Here the LCM is 2a. So here a is present but not 2. That's why we multiply with the 2. That's why 2 into uv 2uv minus 2 into u square 2u square plus. So here 2a is present. That's why nothing to multiply. V square plus u square minus 2uv. So here minus 2uv plus 2uv get cancelled, and here minus 2u square plus u square. So minus 2u square plus 2u square. What we get? We get minus u square. That's why the remaining terms in above equation are v square minus 2u square plus u square is minus u square. That's why v square minus u square by 2a. So from this what we write? V square minus u square is equal, if we take 2a into LHS side, that is 2a into s. That's why v square minus u square is equal to 2as. So this is the third equation of motion. Okay, only you remember these are whenever the acceleration is uniform acceleration, then only we apply the equations of motion.